Alright, we're going to take you for one more trip back to Science 10. We're going to take you for the easiest trip you've probably had in this course so far. And this is a formula that's been ingrained into your brain already. And this is the easiest of the energies. If it moves, it has energy. And we call that energy kinetic energy. So kinetic energy has a nice sweet definition. It's just the energy due to an object being in motion. So it doesn't matter if it moves really fast or really slow. As long as it's moving, it has kinetic energy. So the equation that you learned in Science 10 for kinetic energy is this EK equals 1/2 mv squared. So EK is our kinetic energy in joules, mass has to be in kilograms, speed's got to be in meters per second. So what we're looking at specifically though is this thing called translational kinetic energy. Since we're looking at an object kind of moving along a line from point A to point B, there's also this thing called rotational kinetic energy. So as an object spins, it has kinetic energy associated with that. And there are objects that can have both. So like for example, the Earth is going to have translational kinetic energy by moving in a circle around the sun. But we also know that the Earth is going to orbit around its own axis once every 24 hours. So that also is going to have rotational kinetic energy. So we can have both types of energy. But for us, we're going to stick to translational kinetic energy, or the EK equals 1/2 mv squared. Rotational kinetic energy is beyond the scope in Physics 20. So let's do a very quick example on this. So we have a 12-gram bullet. It has 6,750 joules of kinetic energy. Let's find the speed as it exits the barrel. So the only thing I don't like is I don't like the 12 grams. So we know that there are 1,000 grams for every kilogram. So that is going to give me a mass of 0.0120 kilograms. So I know that EK is 1/2 mv squared. I would like to find V. We're going to multiply both sides by the 2 here. We will get 2EK equals mv squared. And then we're going to divide both sides by mass. Divide by mass. So I'm going to have this 2EK over m equals V squared. Or, you know, we can take the square root of that. So what we're going to find is we're going to find that V is equal to the square root of 2EK over m. Well, we have the kinetic energy, we have the mass. Let's calculate it. So we get 6,750 joules divided by 0.0120 kilograms. So we're going to find that this bullet, it is going to travel quite fast. So it's going to travel about 1,060 meters per second. I'm going to say that the speed's about 1.06 times 10 to the 3 meters per second, or about 1.06 times, or about 1.06 kilometers per second. For a bullet, that seems pretty reasonable. Now you got to keep in mind, bullets do travel fast, but it's not going to travel that speed for very long too, because you also have to keep in mind, bullets are really small. Even though they're aerodynamic, they are certainly going to experience issues with air resistance, and eventually it's going to lose energy and stop. But yeah, bullets very fast to start with.